you do the interior, right? Because you see, it's a circle, right? That means the velocity might be different along the walls, correct?
Can you just cut another plane?
Can do curve one, internal curve.
I not really understand.
Means now you are doing on a YZ plane. So is it possible to, instead of doing just one view, can do
On the wall of the.
The internal wall.
Now it's already internal wall.
Okay, so now
But not-
because
not-
now
not-
you are only contacting the top and the bottom.
Yep.
At one point
And
on
the middle
on the
point,
pipe.
right? Yeah.
So is it possible to touch more point, like let's say a semicircle?
If we do it on the wall, not this.
Not the external wall, but the internal wall.
The external wall is actually internal wall of your pipe already, ma. Correct.
But it's fluid flow,
Yup. Free flow.
of internal.
Okay. Can I draw here?
Yeah, sure. Go ahead.
So for the pipe structure, you have this kind of structure, right? Okay. This is alternate wall, OD, ID. So what is inside here is actually ID.
ID, correct.
It's already ID because you are doing the CFD on the fluid volumes. Okay. So for this particular volume is for the structural simulations, which is here. So later on we will export the fluid pressures to the structurals. Okay. Does it answer your questions? Never mind. Okay. But anyway, if you want to generate the curved surface, like for inside, right, you can just offset it from the planes, maybe.
Then just do nearer to the wall side.
Yeah, but I don't think it's necessary because normally for pipe simulations, right, you just need to know
the center.
Yeah.
Because all the boundary layers are the same.
Yeah,
the
if you
wall
whether cut in this direction or this direction, right, you're almost the same for the pipe.
So can you generate the chart? How to generate the chart?
What kind of chart you want to generate?
Okay, for example, I want the velocity chart over here. How to draw the line? I don't know how to draw the line.
So velocity. Okay, in order to generate the chart, right? Firstly, okay. For contour plot, you need to have a plane.
Okay, need to have a
Plane.
okay.
Okay. For chart, right? You need to have a line.
Yeah, how to
Okay.
draw a line?
So firstly, click on locations, line.
Okay.
Line 1, okay. Then where is your point 1, where is your point 2? Example, if you want to generate
I need to select
at
the
the
plane,
center,
is it?
yeah, the point. So just click on this until it changes to yellow. Then click on the surface here.
But okay.
Then the next one, maybe it has to be a straight line, cannot be a curved one.
Yeah.
Okay, then after that you can fine tune. Oh yeah, just click apply first. So agak-agak lah.
You just change something.
Okay, so at the middle, right? So if example this is the line that you want, then you can go to the charts. Okay, so under XY chart, your data series have to change the location to the line. Okay, and then x-axis is your what?
Velocity.
No,
Does
it's
it
the
matter?
directions. The direction.
X must be direction. So Y is the
Yeah,
velocity.
you can terbalik lah, but normally we won't
Because I-
listen by that, right?
Okay, so X is usually the
Directions.
direction.
Yep.
So
So if
Y
you go
will be
back
the pressure or
the
velocity.
variables. Okay, so your x is actually the z directions. So just change to z, and then your y-axis change it to either
Velocity.
velocity. Then click apply. Then go to chart viewer to get this one. Okay, if example you want to see more so-called smoother line lah, you can increase the point from 10 to maybe
Apply first, then
50.
you see what you get.
You get a smoother line.
So it's there, right? So you want
Meaning-
it in the middle. So it's
Increase the so-called the point that within the
So
line.
it's more jagged, so it's more.
It's more point.
Okay. So
Okay.
this approach 0, this is the outlet lah.
This is at the outlets, correct.
Outlet. That's why I got.
So click your pressure.
It one got.
No, wait. Zero barrage. If you follow the, just go back to here. You follow,
Where is the 0?
should be here.
I thought you selected point 1 to be here.
Yup, point is there, but if you follow the
Oh, from origin. This
global
the
origins,
origin.
correct.
So this is 0.
You have to observe clearly lah. So from 0, right? Okay, then go back to 3D view. Here is 0, right?
Yeah, correct.
Then go all the way to a stabilized velocity.
Ah, okay. Alright, right.
Also here lor.
Can. Understand. Alright, thank you.
Okay, so next,
Yeah.
shall we proceed?
Yes.
Huh? What? Tell you.
Gerald got video.
So we just save the result and then proceed to the structural simulations. This is for what?
Huh?
Oh, this is for the split. So just close it first. Oh.
Close it, close it.
Okay, then this also close. Okay, so we can see all the. Okay, why got no ticks here? But it's okay lah. So this part is done. Then this part is for the static structurals. Okay. So right click on the. No, just double click on the model. You guys? Oh, you already done. So for the geometry, maybe you can change the view to this so that you can see the geometry clearly, and just suppress the fluid regions because you are doing
Because you don't
the
want the fluid.
correct. You are doing structural simulations now. So structure of the pipe is the important thing that you want to so-called analyze. Then just suppress the fluid. Then make sure you have a 打叉 on the fluids. Yep. And left only the solids. Then for the mesh, right, you have to activate the curvatures because this is a round pipe. So you want to refine the or capture the curvature surface. Okay. Next, change all these things to phi.
Fine, fine, right?
Phi. Phi.
What is transition?
Means from, okay, example, from one cell to another cell, then to another cell, to another cell. The transition is like, how does this is actually being transit from one cell to another cell.
Also, instead of a very small one, suddenly become a
Yeah,
big
so if
one.
you use
so if you slow,
slow, right,
means gradually,
gradually,
increase.
yes. If you use fast, right, like this, then suddenly like this, it's not good. Right? Okay, so all this is being defined, right? Then you can just right click and generate mesh. Okay, so the next thing is to. So actually, for structural simulation, what we need is firstly the supports and the loadings.
The
So
of this structure, so
yeah.
you need to set a point.
Like example, cantilever beams. Okay, definitely you have a fixed support here. So what you need to model is just the beam only. You don't need to model this wall. So you can just tell the solver this surface is the fixed support. If example your loading is on this point, right, then you can actually select this point as the loading criteria. Okay.
跟那些的 mechanics one 一样，记得吗？
就是
很多人去画那个 wall，他们讲
Okay, so firstly, we have to select. Maybe we change it to wireframe.
Yeah, 看 nice 啊。
So just select this. this surface so we assume this surface are the fixed supports. Okay, so after we select the surface, then we have to right click on the static structural, insert fixed supports. Okay, so we can see the fixed supports here. Okay, then next we have to import the fluid pressures from the CFD sources. Okay, so right click, insert the fluid pressures. Okay. Okay, so firstly we have to select the internal surfaces that interact with your fluids.
动到的，
啊，
有动到的。
动到的。Then right click, select all. Because it's very hard to select internal surface, so just select everything then
Undo
deselect.
the outside
Yeah,
one.
correct.
那两个也没有动到啊。
那个也没有 so we have to remove that. ，apply. Then make sure what everything inside is selected.
Okay.
Then the safety surface is actually from the wall. Okay. Yeah. So make sure all the yellow highlighted checkbox is defined properly. Then under the solutions, right click, insert. If example we want to find a deformation of the structure, just click on deform or total deformations. And the stress value, parallel stress. Okay. Then just click solve. Yeah, then it will take some time for the solving. You go back to the 3D viewer.